Welcome sa ating new math lesson. Ako nga pala si Sir Waki. At ito ang ating topic ngayon. Permutations. A close friend invited Anna to her birthday party. Anna has 4 new blouses. Stripes, with ruffles, long sleeve, and sleeveless. And 3 skirts, red, pink, and black. Assuming that any skirt can be paired with any blouse, in how many ways can Anna select her outfit? List the possibilities. Possible pair, red skirt and stripes blouse. Red skirt and with ruffles blouse. Red skirt and long sleeve blouse. Red skirt and sleeveless blouse. Pink skirt and stripes blouse. Pink skirt and with ruffles blouse. Pink skirt and long sleeve blouse. Pink skirt and sleeveless blouse. Black skirt and stripes blouse. Black skirt and with ruffles blouse. Black skirt and long sleeve blouse. And black skirt and sleeveless blouse. So the total number of possible pairs is 12. So we can see there are 4 possible pairs when Anna wear a red skirt. And 4 possible pairs when Anna wear a pink skirt. And 4 possible pairs when Anna wear a black skirt. Three times 4, there are 12 pairs. Now, suppose you secured your bike using a combination lock. Later, you realize that you forgot the 4-digit code. You only remembered that the code contains the digits 1, 3, 7, and 4. List all the possible codes out of the given digits. How many possible codes are there? Showing the number of possible codes. So there are 24 possible codes. We have 4 for the first one, then 3 for the second one, 2 for the third one, and 1 for the last one. When we multiply these 4 numbers, 4 times 3 times 2 times 1 is equal to 24. So there are 24 possible codes. Another way of writing 4 times 3 times 2 times 1 is 4 with an exclamation point. This is read as 4 factorial. Similarly, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. That is equal to 120. And 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. And that is equal to 40,320. While 3 factorial is 3 times 2 times 1, which is equal to 6. What about the 1 factorial? 1 factorial is equal to 1. And for convenience, we define 0 factorial is equal to 1. How do we find the permutations of objects? Suppose we have 6 different potted plants and we wish to arrange 4 of them in a row. In how many ways can this be done? We can determine the number of ways these plants can be arranged in a row if we arrange only 4 of them at a time. Each possible arrangement is called a permutation. The permutation of 6 potted plants taken 4 at a time is denoted by any of the following. Similarly, if there are n objects which will be arranged r at a time, it will be denoted by, this is read as the permutation of n objects taken r at a time. The permutation of n objects taken r at a time can be denoted by any of the following. How do we find the number of permutations of n objects taken r at a time? Example, given the 4-letter word READ, in how many ways can we arrange its letters 3 at a time? Solution, there are 3 positions to be filled. We write the horizontal marks. So in the first position, there are 4 letters to choose from. And for the second position, 3 letters. For the last position, there are only 2 letters. Then when we multiply these 3, we get 24. Thus, there are 24 possible ways of arranging the 4 letters of READ, taking 3 of them at a time. We also say the 4 letters of READ, taken 3 at a time, have 24 permutations. Let us take a second look at the example in the previous slide. Remember, n equals 4 and r equals 3. 4 times 3 times 2, and that is equal to n times the quantity n minus 1 and times the quantity n minus 2. Notice that the first factor is n and the succeeding factors decrease by 1 each time. Look at the last factor. So n minus 2 is equal to n minus the quantity 3 minus 1. So that is n minus 3 is r. So r minus 1, or when we simplify, that is n minus r plus 1. Take note also that there are r factors in all, starting with n. So the number of permutations of n objects taken r at a time, where n is greater than or equal to r, is remember, the permutation of n objects taken r at a time is and the permutation of n objects taken all at a time is, try this, find the permutation of the following. So that is equal to 5 factorial over the quantity 5 minus 2 factorial. So that is equal to 5 factorial divided by 3 factorial, which is equal to 5 factorial is equal to 5 times 4 times, now we will stop for the 3 because the denominator is 3 factorial. 5 times 4 times 3 factorial all over 3 factorial. So we can cancel 3 factorial. So 5 times 4 is equal to 20. Eight factorial divided by the quantity 8 minus 4 factorial. And this is equal to 8 factorial divided by 4 factorial. For the numerator, 8 factorial is equal to 8 times 7 times 6 times 5 times 4 factorial. We will stop on the 4 factorial because the denominator is 4 factorial. So we can cancel now 4 factorial. Then we multiply 8 times 7 times 6 times 5, and that is equal to 1608. 6 factorial divided by the quantity 6 minus 1 factorial. 6 factorial divided by 5 factorial. equals 6 times 5 factorial divided by 5 factorial. Then we cancel 5 factorial. The answer is 6. Next, what is the permutation of 7 objects taken 3 at a time? This is equal to 7 factorial divided by the quantity 7 minus 3 factorial. 7 factorial divided by 4 factorial equals 7 times 6 times 5 times up to 4 factorial, since the denominator is a 4 factorial. So we can cancel 4 factorial. 7 times 6 times 5 is equal to 210. We can actually use a scientific calculator in finding the permutation of n objects taken R at a time. Click the subscribe button and the notification bell for more updates of our videos. Math is so easy.